Hello, my dear students. Very good, happy Diwali to all of you. In our present class, we will going to discuss the IUPAC nomenclature of carboxylic acids and also some keto compounds, carbonyl compounds. And then we extend our class to some typical examples of some different kinds of organic molecules and their IUPAC nomenclatures. Hope this class will help you to crack some typical questions in your board exams, and obviously in every entrance examinations such kinds of questions usually asked. So without wasting time, let's focus on the whiteboard. Okay. So first of all, we focus on the IUPAC nomenclature of carboxylic acid. Okay. IUPAC, which carboxylic acids? So what is the main procedure, main formula of the IUPAC nomenclature of carboxylic acid? This is alkane, alkane plus carboxylic acid. So this is oic acid, and after combination it will give alkanoic acid, and that E is to be omitted, alkanoic acid. Okay. So first, what is the formula, chemical formula of and the structure of that functional group, that is carboxylic acid? The formula of carboxylic acid is COOH, and the structure is C double bond O and that side's OH, and the open chain, the open side of the carboxylic carbon is to be attached with any other alkyl group, R group, and you can easily understand why this is called acid, because of the presence of the ionizable hydrogen atom, and after ionization it will give RC double bond O minus plus H plus, and due to the generation of that H plus atom it will be an acid. Okay. So as it can give H plus ion in solution, in which in solution in water it is an acid. Okay. So let's focus on the IUPAC nomenclature. So in our first example, we can see the so this is HCOOH, very simple, the simplest carboxylic acid, HCOOH. So first number in total, how many numbers? How many numbers of carbon atom? Total number of carbon atom. Count it. So here it is 1. 1 means this is meth. So this is methane. Methane plus oic acid, and very basic. This is very basic. So this is methanoic acid. acid, and it is the IUPAC nomenclature. This is methanoic acid, and the commercial name of the methanoic acid, commercial name, what is the commercial name of the methanoic acid? This is called formic acid. This is called formic acid. Okay, so we will move to some typical examples. In the very next, this is CH3 COOH, and all of you know this is called uh, this is called acetic acid and vinegar. Okay, but what is the IUPAC nomenclature? The total number of carbon atom, this is 1, this is 2. So here it is, total number of carbon atom is 2, and while counting the total number of carbon atom in a carboxylic acid, as before the aldehydes and ketone, you should count the carboxylic carbon also. Student often mistake here, they don't count the carboxylic carbon atom, so you should count the carboxylic carbon atom. Okay, so this is number of 2, so this is ethane, so this is ethane plus oic acid, and it will give ethanoic acid. It gives ethanoic acid. Okay, and let's move towards the some typical carboxylic acid. So here it is CH3 C CH3 CH3 COOH. So at first you should identify the long chain. Identify the long chain. Identify the longest chain. Longest carbon chain. Identify the longest carbon chain. So what is the longest carbon chain? And you should start numbering. Start numbering of carbon atom from carboxylic carbon. From carboxylic carbon. So that means uh, here the carbon atom is 1, it is 2, and you can give number 3, this carbon and this carbon, any kind of carbon. So I go to this carbon atom 3, because that CH3 group, this CH3 group, and this CH3 group, and this the 3 CH3 group in circle all are equivalent. So you give any of these 3 carbon atom number 3. Okay, so look, in second carbon atom there is 2 methyl groups attached to the second carbon atom. So these 2 methyl group, that is this one and this one, are acting as substitution. Okay, these 2 methyl groups, this one and this one, look, this one and this one are acting as the substitution. So before numbering, you should tell what the substitutions are and their positions. So the substitution pairs are the two methyl group. Two methyl groups are their substitution. So there is two methyl group, so it should be dimethyl. It should be dimethyl. Okay, and where the two methyl groups are attached, the two methyl groups are attached with this second carbon. So you should go 2 comma 2. Why 2 comma 2? Because 1 2 is for one methyl group and another 2 is for the rest methyl group. Okay, so what happened? So start with 2 comma 2. Look, there is a comma between two numbers and there is a hyphen between number and letter. 2 comma 2 dimethyl, 2 comma 2 dimethyl, and the parent chain is 3, so propane. 2 comma 2 dimethyl propanoic acid, 2 comma 2 dimethyl propanoic acid. Any confusion, friends? If you find any confusion while watching this video, kindly make your comments in comment box, okay, so that I can understand your problems, your confusions. Otherwise I can't get your confusions, I can't get your questions, I can't get your struck where you struck. Okay, so next, move to another example. And I suggest while watching this video you should write all the examples in your copy. Okay, otherwise you will forget after completing the video. Okay, so always write everything in your copies. There is no other way which can substitute writing in your copies. Okay, so next example, COOH, CH2, 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 COOH, and here is two carboxylic group. So students often confuse from where they will start numbering. You can start numbering from any of these carboxylic carbon. So I will start from here. So 1 2, there is no branching, there is no substitution here, it is a long chain. So 1 2 3 4 5. Okay, so it is simple pentane. Total number of carbon is 5, so it is pentane dioic acid, pentane dioic acid. Why di? Because two carboxylic acids are there, two carboxylic acid groups are there, so it is di. Look, here E exists. Okay, so it is pentane dioic acid, not pentan. This is pentane dioic acid. So let's go to some typical examples and of some ester, IUPAC nomenclatures of ester. So first, how does an ester molecule form? Ester, carboxylic acid plus alcohol give ester plus water. Okay, Carboxylic acid plus alcohol gives ester plus water. So it is carboxylic acid and here it is alcohol and can omit. So this will give COOR plus H2O. This is an ester molecule. This is an ester molecule. So in an ester molecule, look, in an ester molecule, R C double bond O bond R prime. So that portion, so this portion comes from carboxylic acid and that portion comes from alcohol. Okay. So the alcoholic part written as alkyl, the alcoholic part written as alkyl, and the carboxylic part is written as alkanoate, alkanoate. So the part comes from carboxylic acid is written as alkanoate, and that part comes from alcohol written as alkyl. So total name, full name of ester. So full name of ester is alkyl alkanoate. Alkyl alkanoate. Okay, friend. So move to a specific example. So if it is given HCOOCH3, HCOOCH3, alkyl alkanoate. Remember, HCOOCH3, HCOOCH3. Okay. So you first write the full formula like this: C of the ester, COCH3. Okay. So that part come from carboxylic acid. So it is alkanoate. So how many carbon is there? There is one carbon. So it is meth. That why it will be methanoate. Methanoate. And that portion comes from alcohol and this part is called alkyl and this is one carbon, so it is methyl. So what will be the full name? Full name will be methyl methanoate. Methyl methanoate. Methyl methanoate. Okay. So move to uh, another example. Here CH3 CO O CH2 CH3. So first write the full formula of the ester. CH3 CH3, CO, O, CH2, CH3. Okay. So this part comes from carboxylic acid and that part comes from alcohol. So which part comes from alcohol? This part. So how many carbons is there? There are two carbon atoms. So two carbon atom means ethyl. So this part is called ethyl. And that part which comes from carboxylic acid consists of two carbon atoms. So this will give as ethanoate. Ethanoate. So full name is ethanoate. Ethyl ethanoate. Which one? CH3, COO, CH2, CH3. Ethyl ethanoate. Let's have another example. CH3, CH. Here it is Cl and it is CH2, COO, CH3. Very easy. That part comes from carboxylic part and that part comes from alkyl, that is come from alcohol. This part comes from alcohol. Okay. So at first you should write the alcoholic part. So how many carbon is there? There is one carbon from the alcohol part. So this is methyl. Okay. But in the carboxylic acid part there is a substitution as chlorine. So as there is a substitution as chlorine, you should numbering the carboxylic acid part, and you should numbering the carboxylic acid part. So from where the numbering will start? The numbering will start from the carboxylic group. That means from here, so 1, 2, 3, 4. Student often mistake here. They start numbering from the alcohol part, but remember, you should not start numbering from alcohol part. You should start numbering from the carboxylic part. Okay, carboxylic carbon, from the carboxylic carbon only. So the carboxylic carbon will get number 1, then 2, 3, 4. That's why the substitution as chlorine situated on the third carbon atom. So at first you should write the alcohol part, that is methyl. This is one carbon atom, so it is methyl. Then write the substitution where it from where it belongs. It belongs to third carbon atom. So methyl 3 chloro, methyl 3 chloro, and total number of carbon atom in the carboxylic part is 4. So this is butane. So this is methyl 3 chloro butanoate. Why it is butanoate? This is alkyl alkanoate. So alkanoate part, that means carboxylic part, consists of 4 carbon atom. That is butane. So it is butanoate. Butanoate. Okay, and there is hyphen between number and letter. Letter and number. Number and letter. Hyphen. Okay. So friends, today we should stop here. In our very next class will get some we will accustomed with some other typical examples and we will follow our next class. Okay, so till then, goodbye, and please, if you get some help from my class, please subscribe my channel and try to follow every lectures. Okay, so you will be certainly benefited from my lectures. Okay friends, till then, goodbye.